So Friday, we learned how to create a new function from two, right? Given two functions, we learned how to create a third function by adding the two functions together, subtracting one from the other, multiplying the two functions together, and dividing one function by the other. Right? So there are four ways that you can create a third function from given two functions. So today we're going to learn the fifth way to create a new function from two functions, and that is by taking the composite of two functions. So we'll demonstrate that right in example 3. You're given f of x is equal to 2 over x plus 3, and g of x is equal to 5 minus x. Now in A, we're going to find the composite of the function f with the function g as a function of x. So this open circle here, right, is not a multiplication symbol. Math is called a composite operator. And it means to take the composite of the function f with the function g. Okay? And by definition, that is equal to f of g of x. G of x is called the inner function because it's inside the function f. And f is called the outer function because it contains the function g of x. Okay. So the first step, I remember seeing this stuff on my ACT math test. I was senior in high school, applied for college. I remember seeing composite functions on there. So I'm presuming you've all had some exposure to composite functions in your high school algebra. So the first step is to replace g of x with what it's equal to, right? And g of x is equal to 5 minus x. And now you got to evaluate the function f at 5 minus x. And to do that, wherever you see an x on the right-hand side of f of x, you replace it with 5 minus x. So when we do that, we have 2 over 5 minus x plus 3. Replace the x here with 5 minus x. And now you simplify the denominator, and you end up with 2 over, what's that, 8 minus x. So the composite of the function f with the function g as a function of x is equal to 2 over 8 minus x. Any questions on that? Finding the composite. All right, in B, we're going to take the composite of function g with the function x as a function of x. Now, are we going to get the same answer? We're using the same two functions. And what we're going to discover is order of composition matters, right? So this, by definition, is equal to g of f of x. Right? F of x is the inner function. G is the outer function. Okay? So the roles are switched. Okay? And so the first step is to replace f of x with what it's equal to. Well, it's equal to 2 over x plus 3. So now we got to find g of 2 over x plus 3. And to do that, right, wherever you see an x on the right-hand side of g of x, you replace it with 2 over x plus 3. So we have g of 2 over x plus 3 is equal to 5 minus 2 over x plus 3. And now to simplify this, we've got to have a common denominator, which is x plus 3. So I got to multiply top and bottom of 5 with x plus 3. I have 5 times x plus 3 over x plus 3 minus 2 over x plus 3. And now you distribute, right, 5 inside the parentheses here, and we can combine the numerators because we have a common denominator now. So this is equal to 5x plus 15 minus 2 over x plus 3. 15 minus 2 is 13. So this simplifies to 5x plus 13 over x plus 3. All right, any questions with that? Okay. So you can take in C, we're going to take the composite of the function f with itself. You can do that. So by definition, this is equal to f of x. So f is both the inner and the outer function in this case. Okay. And so the first step is to replace f of x with the inner function with what it's equal to. And it's equal to 2 over x plus 3. And now we evaluate f of 2 over x plus 3 by replacing x on the right-hand side of f of x with 2 over x plus 3. So this is equal to 2 over 2 over x plus 3 plus 3. And now you should recognize that as a complex fraction. Right? We've got a fraction inside a fraction. This is the main fraction bar. So this is the main numerator. This is the main denominator. So we need to simplify the main denominator. And the common denominator here, down here, is x plus 3. So we multiply top and bottom of 3 by x plus 3. We have 3 times x plus 3 over x plus 3. And now we can combine in this main denominator, we can combine the numerators because we have a common denominator. I can distribute the 3 inside the parentheses. So I have 2 plus 3x plus 9 over x plus 3. This is the main fraction bar. So 2 is the main numerator. Then this quotient is in the main denominator. Two plus 9 is 11. So we have 3x plus 11 over x plus 3. So now we're dividing the number 2 by this fraction. And you remember when you do division with fractions, you do keep, switch, flip, right? So we keep the main numerator, which is 2. We switch division, division to multiplication, and then we flip the denominator. And when we flip the denominator, we have x plus 3 over 3x plus 11. Now we go one step further. The number 2, you know, can be written as 2 divided by 1. So we have 2 multiplied by the reciprocal of this, right? Keep, switch, flip, right? 2 is the same as 1. And now you know when you multiply 2 quotients, you just multiply straight across. So we have 2 times x plus 3 over 1 times 3x plus 11. So that's the composite of f with itself as a function of x. Any questions on yes? Yeah, I mean, it didn't say the factor. Yeah. Didn't say the factor. All right, in D, we're taking the composite of the function g with itself. That's equal to g of x. So this g of x right here is the inner function, and that g out here is the outer function. So the first step is to replace the inner function g of x with what it's equal to. It's equal to 5 minus x. We have g of 5 minus x. And now we evaluate g at 5 minus x by replacing x on the right-hand side here with 5 minus x. So we have 5 minus, and you got to put 5 minus x in parentheses, otherwise you'll just subtract the first term and not the second term. So when you distribute the minus sign inside the parentheses, you have 5 minus 5 plus x, which is equal to x. Composite of g with itself is equal to x. All right, in E, big questions. Okay. In E, taking the composite of f with g and evaluating it at x equals 2. Okay. So by definition, this is equal to f of g of 2. Now in A, we found the composite of f with g as a function of x is equal to 2 over 8 minus x, right? So we're going to solve this 2 different ways, and you have your choice. Okay. The first way is to replace g of 2 with what it's equal to. Well, g of 2 is equal to 5 minus 2, which is equal to 3, right? So g of 2 is equal to 3. And now you evaluate function f at x equals 3. And you have f of 3 is equal to 2 over 3 plus 3, which is equal to 2, 6, which is 1/3. Okay. The alternative is, in A, we found the composite of f with g as a function of x is equal to 2 over 8 minus x. So we can evaluate this by plugging in 2 in for x down here. So we have composite f of g at x equals 2 is equal to 2 over 8 minus 2, which is equal to 2/6, which is equal to 1/3. You better get the same answers up here or something's wrong. Right? So you got two ways of doing this. Right? We found the composite f with g is a function of x in part A. So to answer this question, we can just put in 2 in for x down here. Done. Or you can evaluate the inner function at x equals 2, and then plug that value into the function f. You got your choice. Both will give you the same answer if you haven't made any mistakes. All right. Any questions? So let's flip over our page. Top of page 3. Well, look at all that space I gave you. Isn't that something? All right, you can take the composite of more than 2 functions. You can take the composite of 3 functions, 4 functions, 5 functions, 6 functions, 7 functions, so forth. So in example 4, you're given 3 functions. F of x is equal to x squared minus x. G of x is equal to 3x plus 5. And h of x is equal to the square root of x minus 3. You're asked to find f of g of h of x. So h is the inner function to g, and g of h of x is the inner function to f. And so you just start from the inside and you work out. Okay? We're taking the composite of 3 functions here. So first thing, replace h of x with what it's equal to. Well, h of x is equal to the square root of x minus 3. Now you got to evaluate the function g at the square root of x minus 3. What's g? 3x plus 5. So we got to replace this x with the square root of x minus 3. So we have f of 3 times the square root of x minus 3 plus 5. Now we got to evaluate f at 3 times the square root of x minus 3 plus 5. So on the right hand side of f, wherever you see an x, you got to put this inside what's in parentheses here in place of the x. Okay? So instead of x squared, we have this in parentheses squared. So this is equal to 3 times the square root of x minus 3 plus 5 squared, right? We replace x here. So instead of x squared, we now have this in parentheses squared. And then minus, we can replace x here with what's inside parentheses here. Minus 3 times the square root of x minus 3 plus 5. Does everybody understand how I got that? All right. We're evaluating the function f at this sum here. So this sum goes in for x here and here. So we have this sum squared minus this sum. Okay? And now you got to do the cleanup, right? So we're going to have to FOIL. on the side over here, right? Remind ourselves of what the FOIL is going to look like. So we have 3 times the square root of x minus 3 plus 5 squared. So that's 2, right? So we have 3 times the square root of x minus 3 plus 5 times itself. Right? That's what squaring means, right? You multiply something by itself. And now the FOIL, right? You got to multiply first terms. And when we multiply first terms, I'm not sure what fraction are here. When we multiply first terms, okay, we have 3 times 3, which is 9, and square root of x minus 3 times square root of x minus 3, which is just x minus 3, right? So we have 9 times x minus 3. That's the F in the FOIL. Okay. Now when we do the outer, we have 5 times 3 times the square root of x minus 3. That's 15 times the square root of x minus 3. That's the O. The I is the inner. And again, 5 times 3 times the square root of x minus 3 is 15 times the square root of x minus 3. And then the L is last terms, right? 5 times 5 is 25. So that's what you get when you FOIL this sum squared. Okay? And now you got to distribute the minus sign inside parentheses here. So we have minus 3 times the square root of x minus 3 minus 5. And now it can be just a matter of how you want to simplify, right? Dividing like terms. Okay. So we distribute the 9 here. You have 9x minus 27. And then these 3 guys, 15 times the square root of x minus 3 plus 15 times the square root of x minus 3 minus 3 times the square root of x minus 3. They're called like radicals, right? The radical is the same. So this is like adding 15y plus 15y minus 3y. 15 is 30, minus 3 is 27. So we get 27y. But instead of y, we have square root of x minus 3. So we're adding, subtracting what's called like radicals. So this is equal to plus 27 times the square root of x minus 3. And then 25 minus 5 is 20. And then lastly, minus 27 plus 20 is minus 7. So we have 9x plus 27 times the square root of x minus 3 minus 7. You can't simplify that any further. That's a good review of like radicals, okay? So we add and subtract like radicals, just like adding and subtracting multiples of x or multiples of y. Okay. All right. Any questions on that? All right, in number 5, we're going to do what is called decomposition. You know how to find the composition of two functions. In 5, we're given a function, and we got to find two functions whose composition is equal to big F of x. Okay? That's called decomposition. So what we did here, right, is called composition of 3 functions. In example 5, we're going to do what is called decomposition. Going backwards. So we have big F of x is equal to x plus 2q minus x plus 2 minus the absolute value of x plus 2, right? So big F of x is equal to x plus 2q minus the absolute value of x plus 2. Okay. So we gotta find two functions, f of x and g of x, such that big F of x is equal to little f of g of x. Okay? So we got to find little f and little g so that their composition is equal to this up here. Now remember, g of x is the inner function, little f is the outer function. And so students often want me to give them a formula how to decompose one function into two functions, but there is no formula. You either see it or you don't. So g of x is the inner function. You want to find that first, and then you find and once you define what the inner function is, you automatically know what the outer function is. So what you got to look for in doing decomposition is a function of x inside this function. And if you notice, x plus 2 is a function of x that's inside big F of x. Okay. So we can set g of x equal to x plus 2. That's our inner function. Right. The function x plus 2 is inside big F of x. Now, to get little f of x, you replace x plus 2 with x in big F of x. Okay. So when I replace x plus 2 with x, I have x cubed, right? X raised to the third power minus the absolute value of x. That's my outer function. X cubed minus the absolute value of x. So we replace x plus 2 with x on the right side of big F of x. okay? To get little f of x. Now, how do I know I decompose this big function down into two smaller functions? I do a check, right? Big F of x has to equal the composite of f, little f with little g, right? F of g of x. G of x is equal to x plus 2. This is equal to f of x plus 2. And now to evaluate f of x plus 2, I replace x on the right-hand side of f of x with x plus 2. And I have x plus 2 cubed minus the absolute value of x plus 2. And that matches big F of x over here. Okay. So once you do your decomposition, determine whether it works or not, you do a composition of your two functions to see if you end up with the original function. Okay. If it works, it works. If it doesn't, it doesn't. Okay. But the first step is finding an inner function, right, that is inside the original function. Okay. All right, any questions on that, ladies and gentlemen? None. Okay. So flip over your page. And erase this. Alright, so in 6, you're given f of x, little f of x is equal to the square root of x minus 1, and g of x is equal to 2 over x minus 3. In A, you got to find the composite of g with f as a function of x. See, this is the easy part, right? You given two functions, find their composition. It's a lot harder to be given the composite function and have to decompose it into f little f and little g, right? Because you're going backwards. It's not so obvious, right? It's not so mechanical. Well, this is, excuse me, equal to g of f of x. Well, f of x, right, is equal to the square root of x minus 1. What's g of the square root of x minus 1? It's equal to 2 over square root of x minus 1 minus 3. Any questions on that? In B, you got to find the composite of f with g as a function of x. That's f of g of x. G of x is equal to 2 over x minus 3. Now you got to evaluate f at 2 over x minus 3. That's equal to the square root of 2 over x minus 3 minus 1. And again, to simplify, you need a common denominator, which is x minus 3. So 1 can be written as x minus 3 over x minus 3. And now I can combine the numerators over the common denominator, and I have 2 minus x minus 3 in parentheses. If you don't put x minus 3 in parentheses, you'll subtract the first term and not the second term. And now when you distribute the minus sign inside the parentheses, you have 2 minus x plus 3 over x minus 3. And 2 plus 3 is 5. So this is equal to square root of 5 minus x over x minus 3. So that's the composite of f with the function g.